Hey guys, how you doing? It's Coach Scott. We're going to start our first recording of what we're going to cover after that Unit 0, or the first week stuff of the math, so on and so forth. So what we're going to cover first, and I'll do a Big Bang, or a video on the Big Bang, and then we'll do a video on each of these sections. Okay. So let's go ahead and go into the Big Bang. So the Big Bang. What we see in the universe we know is amazing stuff. We are amazing stuff. All right? And what we call this stuff is matter. Now, human beings, we've always been curious of what stuff is and about the nature of matter. So where did matter come from? What is it made out of? And why does it behave the way it does? So, we've discovered that all the matter in our universe is made up of, this is wrong, it says 118 different types of chemical elements. Now, about 90 of these elements occur naturally. All right. So, where did all these elements that make up the universe, where did it come from? That's what we're going to talk about. Now, if you said that the prevailing theory that where the universe began is the model we call the Big Bang. Now, this was thought to have occurred about 14 billion years ago. Now, what the Big Bang theory is believed that our universe beginning at a single point. Now, this one point was thousands of times smaller than the head of a pin. It was also hotter and more dense than any object we can even fathom or know of today. Now, this heat, okay, we can still measure that with astronomy, and we call it the cosmic background radiation. So, this universe began expanding suddenly and rapidly from this single point. So, every piece of matter, all the stuff in the universe, came from this small, dense point. So, let's have a little break. All right. So, when did the Big Bang happen? 14 million years ago? 14 trillion years ago, 14 billion years ago, within the last 3,000 years, or I have no idea, I need some help. I'll give you 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Hopefully you said C, the 14 billion years ago. Okay. So, 14 billion years ago, in the flash of the Big Bang, high-energy photons, light particles, collided with each other, forming oppositely charged particles. So, when this happened, the oppositely charged matter and antimatter annihilated each other, converting back into high-energy photons or light. Okay? High-energy photons are light. So, in the first seconds of the universe, for reasons scientists cannot explain, it's estimated that one particle of matter for approximately every 1 billion particles of antimatter were not annihilated. Now, why did this happen? Well, if you do that, invite me to your Nobel Prize ceremony. You'll get it. So, 3 major particles were formed. One was positively charged particles, the other were neutrally charged particles, and then we also had negatively charged particles. So, what are these positive, negative, and neutral particles called? What is the magnitude of their charge? What are their masses? Let's look. So they're called protons, neutrons, and electrons. Protons are positive, neutrons are neutral, and electrons are negative. The charges on them, all right, is the charge on a proton is positive 1.6 times 10 to the minus 19th coulombs. All right. Neutrons is like neutral, and electrons is minus 1.6 times 10 to the 19th coulombs. So they're both the same. Now let's look at their masses. A proton is 1.67 times 10 to the minus 27th kilogram, very small number. A neutron is 1.67 times 10 to the minus 27th kilogram. Again, about the same size. So a proton is approximately the same mass as a neutron. Now let's look at electrons. The electron's mass is 9.1 times 10 to the minus 31st kilograms. So that's smaller than a proton or a neutron by a factor of 4. So they're much smaller than than the other two. All right. Oh, gosh, sorry, hit too many. So as the universe expanded, the plasma and the radiation filling it grew cooler. When the universe cooled and stable atoms could form, they eventually could no longer absorb the thermal radiation, and the universe became more transparent instead of being an opaque fog. Now, the photons that from that time have been propagating ever since, growing fainter and less energetic. All right. Well, so off we go. So which of the pieces of evidence support the Big Bang Theory? A fossil carbon dating? Evolution of life on Earth? Cosmic background radiation? Observation of the sun's rays? I have no idea. Hopefully you said C. C. Cosmic background radiation. So, following the Big Bang, the universe expanded and then rapidly stopped expanding. Expanded and has not stopped expanding since. Rapidly expanded, then shrunk back to its original size of a pinhead. Expanded and then began shrinking over time? Or I need some help. Hopefully, you answered B. Expanded and has not stopped expanding since. So, 3 minutes after the Big Bang, the universe began to cool down. Wow. It went from 1 times 10 to the 32nd Celsius. That's pretty hot. That's 1 with 32 zeros after it. To 1 times 10 to the 9th or 1 billionth or 1 billion degrees Celsius. And that's still hot, but not as hot as that. And protons and neutrons begin to combine. There's a proton, there's a neutron, there's a proton, there's 2 neutrons. All right. So after about 300,000 years later, as they started to still continue to cool, the universe had cooled enough for positively charged protons to attract the negatively charged electrons. All right. And the first atoms were formed. So hydrogen, 1 proton attracted the electron, and so they were spinning around. This is hydrogen 1. There's 1 proton. This is hydrogen 2. Still 1 proton, but it now has a neutron and also has 1 electron rotating around it. Notice this is hydrogen 2. Another name for it is deuterium. Tritium is hydrogen 3. Again, 1 proton, 2 neutrons for a total of 3 particles in the nucleus and 1 proton floating around. All right, so helium also formed, had 2 protons, 2 neutrons, that's helium-4, and 2 electrons. So 4 particles in the nucleus. Lithium-7, 3 protons, 4 neutrons, for a total of 7 particles in the nucleus, 3 electrons in orbit. Beryllium-9, 4 protons, 5 neutrons, so a total of 9 particles in the nucleus with 4 electrons floating around it. Now, during the formation of the universe, only atoms of the lightest elements, hydrogen, helium, lithium, beryllium, were formed, the first 4 elements. Now, as this cloud of cosmic dust and gases from the Big Bang cooled, all right, stars formed, and these then grouped together to form galaxies and stars. The high pressure and temperature within stars cause protons and neutrons to fuse together. In smaller stars, and our sun Sol is pretty small, the temperatures are 15.5 million degrees C at the core, and that's hot enough to make helium from hydrogen only. So you'll have 2 hydrogen atoms, they'll fuse together, and they'll form helium. Now, in the core of hotter, larger giant stars, like a red supergiant or a red giant, and there's our little bitty sun right there. Helium will fuse to make atoms with 4 protons. We call it beryllium. Helium and beryllium fuse to make atoms with 6 protons. We call that carbon. Now, carbon and helium fuse and make atoms with 8 protons. Oxygen. And in this manner, with up to 12 protons formed, we form elements. So all these suns are, all these stars are giant atomic factories. It's pretty cool. Now, atoms of elements, aluminum to iron, they formed in supergiant stars. So from 13 to element 26, iron, they form in these supergiant stars. Now, the most massive elements from iron to uranium were created in star explosion. We call those supernova. Now, this is a pretty good little periodic table of how the origin of the things we call elements. So the Big Bang created hydrogen and helium over time. Cosmic rays and that little soup of the right after the Big Bang, we formed lithium, beryllium, and boron. Then small stars and large stars will form carbon, nitrogen, oxygen, fluorine only in large stars. Neon and small stars are large stars. Supernova, they would form iron or cobalt or nickel, the rest of them, right? And then we have some man-made elements and some more up here, right, that we make ourselves. And they don't last very long. We'll talk about those later. So, we're star men. We're star women. So when we say that we matter, we are matter. All right? Atoms, the building blocks of matter, which we're made of, formed in the intense heat and pressure of the early universe in stars, in supernova. So everything around us was once part of a star. So, in this course, guys, we're going to explore the nature of matter and apply the principles of physics to understand their atomic structure, the chemical properties, and we'll be able to predict chemical behavior. And it all came from stars. We'll start on this one next. Thank you, guys, and we'll talk to you later. Coach Scott out.